In this lesson, we're going to be starting with a series of lessons that review some 8th grade standards that we'll need when we talk about some of the next things in our Math 1. The first thing we're going to talk about are perfect squares and what a perfect square is. The square of an integer is called a perfect square. And the first 10 perfect squares you need to know by memory. And honestly, I would say the first 15, because these are ones that you might have to do without a calculator. The square of 1 is 1, because 1 squared equals 1. 2 squared equals 4. So the square of 4 is 2. 3 squared is 9. 4 squared, 4 times 4 is 16. 5 squared is 25. 6 squared is 36. 7 squared is 49. 8 squared is 64. 9 squared is 81. And 10 squared, 10 times 10, is 100. So the opposite of squaring something is to find the square root. The opposite of squaring a number is finding the square root. Positive numbers have 2 square roots. Positive numbers have 2 square roots because if you think about it, what numbers can you square and get 16? Well, you could say 4 squared because 4 times 4 is 16. Or you could say negative 4 squared because negative 4 times negative 4 is also 16. Negative numbers have 0 square roots. What number only has 1 square root? So your positive numbers have 2 square roots. Your negative square roots don't have any. So the only number that only has 1 square root is 0. Now when we talk about square roots, we use a special symbol. We use a symbol called the radical sign. So what that looks like is the square root of x, or the square root of a number. And it's used to indicate the square root of x. So you could say this symbol is used to indicate the positive square root of x. And then if we're talking about the negative, it would look like this. So you have the negative on the outside, indicates the negative square root of x. So let's look at a few examples. The square root of 49. So to think about what this is, you want to think about what number can you multiply by itself to get 49. And we know that 7 times 7 equals 49. So the square root of 49 is 7. We would do the same thing for the square root of 9. 3 times 3 equals 9. So the square root of 9 is 3. Now with the negative square root of 4, so we want to kind of imagine that negative's not there. So 2 times 2 is 4. So the square root of 4 equals 2, but then you have the negative sign on the outside. So the negative square root of 4 is negative 2. The negative square root of 289. So this is one that's beyond 15. So it's one that you don't necessarily have to have memorized. You want to have 1 through 15 memorized. So you would be able to use a calculator for this one. The negative square root of 289 equals negative 17. Go ahead and highlight number 5 and 6. Now number 7 through 9 look a little bit different because you have a fraction underneath the square root. When you solve these, you just want to separate that fraction into the square root of 1 over the square root of 16. And find the square root independent of each other. So the square root of 1 is 1, and the square root of 16 is 4. So the square root of 1/16 is 1/4. Go ahead and highlight number 8 and 9. Now, we have numbers that are called non-perfect squares. So non-perfect squares, your square root is going to be a long decimal. And those are ones you have to do with a calculator. So what we want to do here is we want to circle each perfect square. So that means we can think of a number, multiply it by itself to get this number. So 9 is a perfect square because we can say 3 times 3 is 9. 21 is a perfect square because we can say 11 times 11 is 121. 32 would not be a perfect square because there's not one whole number we can multiply by itself to get 32. Go ahead and highlight 50, 1, 160, 64, 200, and 324. Now, if it's not a perfect square like 9 or 121, we call that a non-perfect square. And you're going to get not a repeating decimal, but a non-terminating decimal. So when you put that in the calculator, so if you put the square root of 32 in your calculator, you get a really long decimal number. But what we can do with those non-perfect squares is we can estimate what the value is. So we know that the square root of 10 is not perfect. So what we want to do is we want to estimate what that is without a calculator. So we have to think about what are your two perfect squares that are on either side of 10. So it's very helpful to have your list of perfect squares. So we're going to list those at the top of the page. You have the square root of 1, the square root of 4, 9, 16, 25, 36, 49, 64, 81, 100, so that's through 10, but remember we want to know through 15. So the square root of 121, 144, I'm going to run out of a room, I'm going to come down here. So the square root of 169, 196, and 225. So these are all in order from 1 to 15. So the square root of 225 equals 15. So these are the ones that you're going to want to have memorized because you won't necessarily have a calculator with these. So if we think about the square root of 10, if we were to place this in our list, keeping it in numeric order, it would fit right here between 9 and 16. So those are our two perfect squares that are on either side of the square root of 10. The square root of 9 and the square root of 16. Now when you think about the number 10, it's closer to the number 9. So if we're estimating, the square root of 10 would round to 3. So if you put in the square root of 10 into your calculator and you round that off to the nearest whole number, it would round to 3. So we can do the same thing with the square root of 15. Looking at my list, I could fit 115 between 100 and 121. So that means I could split it between the square root of 100 and the square root of 121. Now, when I think about, is 115 closer to 100, or is it closer to 121? Well, it's going to be closer to 121. And the square root of 121 is 11. Then again, if you put the square root of 115 into your calculator, round it to your nearest whole number, you get 11. Go ahead and highlight number 12, 13, and 14, and let's look at number 15. So the difference between this one is that you have the negative on the outside, so the negative square root of 206. So you still want to find out where you would put it in line in numeric order. So that would fit between 196 and 225. So we can split that. The square root of 196 and the square root of 225. Then we want to think about, is 206 closer to 196 or closer to 225? And it is closer to 196. And the square root of 196 is 14. But then we don't want to forget that negative that was on the outside, so it would be negative 14. Now for 16, 17, and 18, I want you to highlight those. But I just want you to approximate, so you can mark out to the nearest tenth. Okay, you're going to be doing just like you did 10 through 15. Now, along with perfect squares, we have what we call perfect cubes. So the cube of an integer is called the perfect cube. So remember, cubing something is raising it to the third power. And these you want to have 1 through 10 memorized. So 1 cubed, 1 times 1 times 1 is 1. 2 cubed, 2 times 2 times 2 is 8. 3 cubed is 27. 4 cubed is 64. 5 cubed is 125. 6 cubed is 216. 7 cubed is 343. 8 cubed is 512. 9 cubed is 729. And 10 cubed is 1,000. So again, with the cubes, you want to have 1 through 10 memorized. Those are ones you are expected to know without a calculator. So the opposite of cubing a number is finding the cube root. And all integers only have 1 cubed root. So it's not like with square roots where you have a positive and a negative of it. Only cubed roots have 1. And that's because if you're thinking about the cubed root of 8, 2 times 2 times 2 equals 8. But negative 2 times negative 2 times negative 2 does not equal 8. It equals negative 8. Now the way we write it, we're still using the radical sign. But if you notice, it has a 3 up in the left corner. That is indicating the cubed root of x. So when we think about what is the cubed root of a number, we want to think along the same lines. What number can I multiply to get the number underneath the square root? But I'm going to multiply it 3 times. So I know that if I multiply 4 times 4 times 4, I get 64. So the cubed root of 64 equals 4. For number 21, the cubed root of 343. So I have to think, what number can I multiply by itself 3 times to get 364? And that would be 7 times 7 times 7 equals, 343. So the cubed root of 343 is just 7. Now number 21, we have that negative sign underneath it. So the cubed root of negative 27. So we can think of this as just what's the cubed root of 27? Because I know 3 times 3 times 3 is 27. But I'm trying to get a negative 27. So negative 3 times negative 3 is 9. And 9 times negative 3 is negative 27. So the cubed root of negative 27 is negative 3. So you want to think about that negative if your square root underneath it is negative, or your cubed root. Go ahead and highlight 22, 23, and 24. Now I do want you to write something in your summary to help you remember. 2 things. 1, for square root, without a calculator. So the ones you can do without a calculator, it's 1 through 225. So if you have a number bigger than 225 underneath your square root, you can use a calculator. Anything smaller than that, you have to be able to do without a calculator. The other thing is with a cubed root. Without a calculator, 1 through 1,000. So anything underneath your cubed root that's bigger than 1,000, you can use a calculator for. So remember, so that's going to be for your square root, that's numbers 1 through 15, your cubed root 1 through 10. You're going to want to have those memorized. The next part of our lesson, we're going to use what we just talked about with square roots and apply it to what we call Pythagorean theorem. So the first thing about Pythagorean theorem you need to remember is that it can only be applied to right triangles. So this method is only for right triangles. Now when you have a right triangle, remember it's denoted with a right angle, either with the square or labeled 90 degrees, and you have sides A, B, and C. So your side directly across from that 90 degree angle is always going to be side C. Then your other 2 sides are A and B. And A and B can be switched back and forth, used vice versa. The only one that matters is that diagonal across from your 90 degrees is C. Now sides A and B, we call those our legs. And then side C is called our hypotenuse. And again, this is just for right triangles. So we can use the Pythagorean theorem to find missing side lengths. So that's the purpose of it. And again, it's to find missing side lengths of right triangles. And the Pythagorean theorem has a formula. A squared plus B squared equals C squared. So let's use the Pythagorean theorem to find a missing side. So number 1, I have a right triangle because it's denoted with the square, and I have a missing side. So that's how I know I need to use A squared plus B squared equals C squared. Remember, A and B are your legs, so that's going to be 12 and 5. So I can replace A and B in my formula with 12 and 5. And then I'll leave C squared just C squared. Remember, A and B can be used vice versa, so it doesn't matter which one you plug in for A or B. Then we solve it. 12 squared, because I know my perfect squares and those square roots, I don't need a calculator, it's 144. Plus 5 squared, 5 times 5 is 25, equals C squared. 144 plus 25 is 169, equals C squared. Now our goal is to solve for c. So we're not done. We have to get rid of that squared. And remember, the opposite of squaring something is to find the square root. So we're going to find the square root of both sides. And that would give us c equals, again, I know my perfect squares, the square root of 169 without a calculator is 13. So my side length that's missing is 13. Another important thing you want to keep in mind, we'll make a note of it over here to the side, is your hypotenuse is always your longest side. So when you're working these problems, one thing you want to check when you're done is making sure that diagonal is the biggest number out of all three of them. Number 2, again, I'm dealing with a right triangle and I have a missing side. So I can use a squared plus b squared equals c squared. I'm given a and b, my two legs, so 15 squared plus 18 squared equals c squared. I know that 15 squared is 225, plus I can use a calculator to calculate 18 squared because it's bigger than the ones I have to have memorized, and that is 324 equals c squared. 225 plus 324 is 549 equals c squared. And again, I'm solving for c. So I have to have c completely isolated. So I'm going to find the square root because that's the opposite of squaring. And 549 is not a perfect square. Even if it was, it's bigger than the ones that I have to know. So I can use a calculator. The square root of 549, and we're going to round to the nearest tenth because my directions tell me to, is 23.4. So my missing side length is 23.4. And again, that hypotenuse should be the longest. And when I look at my three numbers on my triangle, it is the longest. Go ahead and highlight number 3 and number 4. Now the problems we just looked at, your hypotenuse was missing. But you could have any of your sides missing. So the next ones we're going to look at is if I have a leg that's missing. So number 5, it's a right triangle, and I have a missing side. So I know I'm using a squared plus b squared equals c squared. Now if you notice, our hypotenuse, the one directly across from the right angle, is not missing. So 10 is c. So we're going to plug in 10 for c. Now remember, a and b don't matter. So I'm going to leave a as a squared because that's going to be my missing side. Plus b is the other leg that I know. So 8 squared. And if it's helpful, you can label that in the triangle. A, B, and C. So now I'm going to solve it. As I solve this one, it's going to be a little bit different than the ones we did before. I'm still going to square stuff. So a squared plus 8 squared, 8 times 8 is 64, equals 100. 10 squared, 10 times 10 is 100. But now, in order to isolate a, I need to solve the equation by doing the opposite. So instead of adding 64, we're going to subtract 64 from both sides. So I get a squared equals 36. And again, I'm still just trying to isolate that variable, so I have to get rid of the squared. And the opposite of squaring is the square root. And the square root of 36, I know without a calculator, is 6. So my missing leg is 6. So when I look at my three sides, 6, 8, and my hypotenuse of 10, that hypotenuse of 10 is still my biggest one. Number 6, I have a right triangle with a missing side. So I can use a squared plus b squared equals c squared. My hypotenuse is not missing. So remember, it's the one across from the right angle. It's always your diagonal. So I can substitute in 25 for C. And then my two legs, I'm going to leave A as A squared. And I know my other leg is 23 squared. So then I square everything. A squared is A squared plus 23 squared, I can put that in a calculator, is 529 equals 25 squared. Again, it's bigger than the ones I have to know, so 25 squared is 625. And remember, our goal is to solve this equation, is to isolate that A. So we're going to start by subtracting 529 from both sides. We're doing the opposite. So A squared equals 96. I'm not done. I have to get rid of the squared. And the opposite of squaring is to find the square root. And I know 96 is not a perfect square, so I can use a calculator. The square root of 96, again rounding to the nearest tenth, is 9.8. So my missing leg is 9.8. And when I look at my three sides, I need to make sure that the hypotenuse is still my longest, and it is. Go ahead and highlight number 7 and 8. And then highlight 9 through 14. So 9 through 14 is still what we just did, but they're mixed up. So some of them your leg is missing, some of them your hypotenuse is missing. So make sure you're paying attention to which one is missing. And make sure you're only using a calculator for those that are bigger than 225. And one more thing with Pythagorean theorem is you should be able to test to see if a triangle is a right triangle. So if I give you the three sides, remember, your biggest side is your hypotenuse. So when I look at number 15, my side lengths are 10, 15, and 20. So my longest side is 20. So this would have to be C, my hypotenuse. My other two sides can be A or B. It doesn't matter. So I'm just going to say the first one's A and the second one is B. So to test it, to see if it's a right triangle, I'm going to plug it into A squared plus B squared equals C squared. So that's 10 squared plus 15 squared equals 20 squared. I know that 10 squared is 100. Plus, I know 15 squared is 225 equals 20 squared. You can multiply it out or you can put that in a calculator. 20 times 20 is 400. Then, I know 100 plus 225 is 325 equals 400. Now here, I get a statement that is not true. 325 does not equal 400. So that means no, these side lengths would not create a right triangle. Let's look at one more. Again, when you're given the three sides, you want to first identify your longest side. And we know that this should be my hypotenuse if it's a right triangle. My other two sides are A and B. And it doesn't matter which one is which. And I'm going to plug those into A squared plus B squared equals C squared. So that is 7 squared plus 24 squared equals 25 squared. 7 squared is 49 plus 24 squared, I would need a calculator for, is 576 equals 25 squared, again, a calculator can be used, is 625. Now 49 plus 576, I can put that in a calculator. I get 625 equals 625. So this one does create a true statement. So that means yes, these three sides could form a right triangle. Go ahead and highlight 17, 18, 19, and 20. And remember, as you're looking at these, you pick out your longest side first, that is C, and then the other two would be A and B, and they must create a true statement at the end to be a right triangle.